In this video, I'm going to model the resolution of vectors into its components, and I'll be using velocity as an example, and I'll provide an example in the context of projectile motion. So in our first scenario, a boat sails 20 knots in a 30-degree northeasterly direction, and there's a current pushing north. So what we want to do here, we'll state that north is in an upward direction on the page. So if north is in that direction, east is going to be to the right. So the boat will be travelling in roughly this direction. So its velocity or its speed in this direction is 20 knots. And what I want to do now is break it down into its components. Its easterly component, so what's its velocity travelling to the east, and its northerly component. So what's the velocity of the current? So the way that I'm going to do that is by using my trig ratios. So I've got SOHCAHTOA, and I also left out of my diagram just then, I also have the size of the angle there, 30 degrees. Okay, so that makes this our adjacent side, and this is our opposite side, and this is our hypotenuse. So in order to find the opposite side, I'm going to use sine. So sine of angle 30 is going to be equal to the opposite side over 20 knots. So the length of the opposite side is going to be 20 times sine 30, which is going to be 10 knots. So what that's saying is that the speed of the current is 10 knots and the direction is a northerly direction. So the current's travelling at a velocity of 10 knots northerly or north. And to find the length of my adjacent side, I'm going to use cosine. So cos 30 is equal to the adjacent side over 20 knots. So the adjacent side is 20 times cos 30, which is going to give me 17 knots. And the direction is east. Easy. Now I will model that exactly the same thing within the context of projectile motion. So in this scenario, Gary throws a tennis ball for his dog. The initial velocity of the ball is 3 meters per second on an angle of 60 degrees from the horizontal. So we've started off with a ball there. I'm just going to move that. That's going to be annoying. So we've started off with a tennis ball over here, and it has been thrown. And the initial velocity is going to be 3.0 meters per second. And we want to break it down into its components, its horizontal and vertical components. Okay, something that is important to remember here that can be a little bit confusing, we're working with the velocity vector. So when we find the length of this side of the triangle, we have not determined the height of the ball at the top of the throw. We have found what is the speed of the ball travelling in an upward direction. It's important just to remember that. We're going to use the exact same ratios that we used here. And again, I forgot to add in the angle there. Okay, so to find the length of this side, this is going to be my opposite side, and that'll be my adjacent side. So it's going to be sine 60 times 30 is equal to the length of the opposite side. So that is going to be 2.6 meters per second, and I'm going to state that the direction is y, as in the y-axis. So I should have done that at the start, I suppose. Y, x. And to find the length of the adjacent, I'm going to use cosine, and that will be 1.5 meters per second in the direction x.